Hi guys, this is day 25 of the A2 Economics Revision Challenge, and today we are doing cost in the short run. Before we talk about cost in the short run, I would like to talk about cost in economic sense. So there is a difference between what we call economic cost versus accounting cost, and that's the distinction that we need to understand. When you look at cost, economists will consider all the costs and even the opportunity cost of any transaction or of any expenditure. It is a cost of any activity which is measured in terms of sacrifice made in doing it. So when we look at opportunity cost, for example, let's say if I own land, let's say, and I am growing crops on it, there is a cost which is called opportunity cost of using that land, which will also be considered in terms of the rent forgone or what I could have done otherwise using this land. So when we look at opportunity cost, it's a cost that we consider in economics, but that's the cost which accountants may not consider. And that's why we have a distinction between what we call explicit cost versus accounting costs. Uh, Explicit cost is the cost which only includes those costs which are considered by accountants, but implicit cost is those costs that also considers what we call opportunity cost. And therefore, when you look at economic cost, we say economic cost is simply implicit plus explicit cost. So let me write this: implicit plus explicit cost. So what is explicit cost versus what is implicit cost, and why does accountant fail to consider implicit cost but will consider only explicit cost? So let's talk about that. We say when factors are not owned by the firm, there is what we call an explicit cost that happens. So let's say if I don't own a shop that I'm working on, I'm going to be paying a rent, and that rent will be what we call an explicit payment made to, let's say, the landlord of that shop. Similarly, if I own the factor of production, then I may not make that explicit payment, because when I owned the shop, I may not be paying anyone the rent. That would mean basically when you own a factor of production, then you are basically doing what you're not incurring any cost which is made from one party to another, but still there is what we call one cost, which is what we call opportunity cost. So therefore, when we own factors of production, we are paying money to when we're not owning a factor of production, we're paying money for that factor of production. That becomes an explicit payment, and accountants consider that explicit payment because that's the money that has changed hand from one person to another. So because the money has changed hand from one person to another, it can be accounted for, and that's why it's an explicit payment. But if I own a factor of production, then I don't really make that explicit payment because I don't need to, because I own that factor of production. But do I incur a cost? And the answer is yes, we incur what we call an opportunity cost, which is why, because we could have given this to somebody else and gotten ourselves rent, or we could have used for an alternative use, which means there is still some money foregone. So from an accounting perspective, only explicit cost is considered. From an economic perspective, both explicit cost plus implicit cost is considered, and that's what we call an economic cost. Now this brings us to the next discussion, which is basically our discussion about what we call fixed, variable, and total cost. We say this, that total cost is equal to fixed cost plus variable cost. So economists basically distinguish between two kinds of costs, which is called fixed cost and variable cost. We say fixed cost is the cost which is also called sometimes indirect cost or overhead cost, is a cost which does not directly vary with the level of output. As the production level changes, as quantity goes up, the fixed cost remains constant. And the reason why it remains constant is because the fixed cost is associated with what we call our fixed factor. Remember, in our last video we talked about fixed factors, like for example capital is a fixed factor, and the rent from that capital will be what we call a fixed cost. Why? Because this is the cost that does not change as output changes. So that's why fixed factor, like for example capital, can incur what we call a fixed cost, which stays constant as the quantity of output goes up. We don't vary it when the output goes up. On the other hand, when we have variable cost, which is called direct cost, is a cost that varies directly with the level of output. So as Q goes up, the variable cost goes up. Why? Because it is associated with our variable factor. When we hire more variable factor, we are we are producing more output because the variable factor goes up. Like for example, labor is a great example of a variable factor. So when the labor employed goes up, then the variable cost is also going up because we are producing more output. It is the variable cost or variable factor that makes the more output. Now what I want to do is basically explain the diagrams which is associated with what we call short run cost. And before we do that, I just want to quickly recap a small concept that we learned in the last video. We said this, that your total output, total product or total output TP, when you have your quantity of labor in your x-axis, increases in this manner. Initially it increases at a faster rate because MP is going up, then it rises at a slower rate, and then it could fall. Right. On the other hand, when you look at MP is like this. When you have the same quantity of labor here, right, and you have MP here, MP initially, when TP is rising at a faster rate, MP is rising, but then TP rises at a slower rate, which is where we will see MP is falling, and then MP can becomes negative. So let's call this as Q1 of labor versus Q2 of labor. So till Q1 of labor, MP is going up or TP is rising at a faster rate, and then till from Q1 to Q2, MP is falling because of the law of diminishing return, and that's why TP is rising at a slower rate and then MP falls. So why am I doing this? Because this production sort of analysis has a very important implication on the cost of production in the short run. So when you look at cost in the short run, I'm going to first make my total fixed cost. My quantity of output is here, so there is a distinction. On my production I have quantity of labor. In my sort of cost graph, I'm going to make quantity of output. So if I have quantity of output here, and if I have cost here, the first thing I'm going to draw is a straight line, which is my fixed cost. My fixed cost does not change as I produce more output. So this is my total fixed cost. But what about my total cost? My total cost will be basically when I'm making 0 unit of output, my total cost will be my fixed cost. So it will be start from here. Why? Because irrespective of whatever I make, I still have to pay my fixed cost, which is the cost which is incurred irrespective of how much we make. The total cost, in fact, will behave in this manner. Initially, total cost will rise at a slower rate, and then it will start to rise at a faster rate. And I'm going to talk about this in 1 minute. And I'm going to say this, that the Q1 workers makes small Q1 output. Let's say Q1 workers are 2 workers. 2 workers make, let's say, 20 units. So this is 20 units of output. Then beyond that, from Q1 to Q2, total cost is rising at a slower rate. So here total cost is rising at a faster rate, and then a slower rate, and then total cost rises at a faster rate. Why is that so? For that, I want to talk about a quick discussion about MP. So look at this, guys. When your MP is rising, which means total product is rising at a faster rate. This is where workers are extremely productive, which means they're adding more and more to output because they're using the capital better and so on, or specializing and so on. So when your output is rising at a faster rate, your cost is rising at a slower rate, and that's why your total cost rises at a slower rate. On the other hand, when your output is rising at a slower rate, because diminishing MP are happening, total cost is rising at your MP is falling, your total cost will rise, or total cost rises at a faster rate. And therefore, the reason why total cost rises at a faster rate is because MP is falling. The reason why total cost is rising at a slower rate is because MP is rising. It's MP that is making total cost to behave like that. And if I want to draw my total variable cost graph, total variable cost graph will be like this only. The only difference between total cost and total variable cost will be basically the fixed cost. So my total variable cost graph will look like this. It's a graph which is completely parallel to total cost graph, and the difference between this is your fixed cost. Make sense? Now to look at total cost, we said this total cost is initially rising at a at a slower rate, and then total cost rises at a faster rate. So when we say rate, we're looking at slope. Remember this, that rate in economics means that we're looking at the slope, and the slope of total cost curve is called basically the marginal cost curve, where the formula for slope is change in y over change in x. So for example, here the slope of total cost, the slope of total cost will be change in y over change in x, which is basically simply your change in TC over change in quantity of output we're looking at, which is simply what we call our marginal cost. Marginal cost is the cost of producing an extra unit, and it's an important curve to understand, because initially total cost is rising at a slower rate, which would mean if I draw my graph for marginal cost, so I'm going to have same sort of Q1 and Q2 units, and on my y-axis I have marginal cost, and my x-axis I have quantity of output. So when we look at it, initially total cost is rising at a faster rate, at a slower rate, because of the fact that MP is rising, which would mean marginal cost is falling. What is marginal cost? The cost of making one extra unit, which is the slope of, because total cost is rising at a slower rate, marginal cost is falling. Then total cost start to rise at a faster rate, and that's where we will see marginal cost starts to rise. So marginal cost will start to rise after Q1. Now marginal cost and marginal product have an inverse kind of a relationship. When your MP is rising, MC is falling. When MP peaks, let's call it point X, when MP peaks, this point Y is where MC will be at its minimum, and when MP falls, marginal cost rises. So there's an inverse relationship with MP and MC, where MP rises, MC falls. So when workers are extremely productive, total output is rising at a slower rate, at a faster rate, but total cost is rising at a slower rate, which means MP rises, MC falls. Then when MP falls, when workers' productivity is going down, this is where the marginal cost starts to rise. And where MP peaks, MC is at the minimum. This brings us to the next part of our discussion, which is basically discussing our average cost. So if I look at the relationship between marginal cost and average cost, marginal cost and average cost has something like this of a relation. So this is, let's say, my marginal cost curve. It falls and then it rises because of the law of diminishing return, where let's say Q1 is the point where MC is at its minimum, and beyond that the law of diminishing marginal return happens. Now if you want to draw our average cost curve will be like this. Average cost curve will fall, and as soon as it meets MC will start to rise. In other words, average cost is a U-shaped curve, or average total cost curve is a U-shaped curve, which is at its minimum when it meets MC. And the reason why it happens is the same as what we discussed in the average product and marginal product curve. We said this, that when the margin is below the average goes down, and when the margin is above the average goes up. So when MC is below ATC, it pulls down ATC. When MC is above ATC, it pulls up ATC. So that's why ATC becomes a U-shaped curve, where it meets MC at a lowest point. For example, like this point X, or let's call it in fact something else, this point E, which is the minimum point of ATC. Now when MC before E point, ATC was going down, and after E point, ATC is going up. So therefore, at E, we say ATC is at its minimum. So one thing also we need to look at is just that MC meets ATC at ATC's minimum point. Lastly, we want to discuss about average variable cost. So AVC and ATC will have a relationship like this. So I want to talk about this quickly. When you look at AVC and ATC, ATC is U-shaped and AVC is also U-shaped but has this relationship which is such that the gap between ATC and AVC is shrinking as quantity goes down, as quantity goes up. And the reason why this happens, let me write this ATC comma AVC, is that the gap between these two graphs is your average fixed cost graph. So average fixed cost is a graph. Remember, when we say fixed cost is like this, right? As quantity goes up, fixed cost remains same. As you produce more and more units, fixed cost remains same. So average fixed cost, when fixed cost is constant, average fixed cost, which is fixed cost over Q, will be like this. Keeps on declining as quantity goes up when we produce more of the good. And the reason is very simple. Where the fixed cost is constant, quantity is going up, average fixed cost will fall. So this gap between these two graphs, AFC and ATC and AVC, is AFC. Why? Because we know just that ATC, average total cost, is equal to average fixed cost plus average variable cost. And when you look at marginal cost should meet ATC and AVC at their lowest point. So when you look at marginal cost curve, marginal cost is meeting ATC and AVC at their lowest point respectively. So a couple of things to remember. Number one, marginal cost falls and the marginal cost rises because of the law of diminishing return. Number two, ATC and AVC has a gap which is called AFC, which keeps on declining because fixed cost is constant. Number three is MC meets ATC and AVC at the lowest point of these two graphs. So that's an important thing to understand for the cost curve. So just a recap also of another concept, which is that when MP rises, MC falls. When MP falls, MC rises, again because of the law of diminishing marginal product. Probably the law of diminishing marginal product is the most important concept when it comes to cost and when it comes to production. The last concept in terms of short-run cost is the concept of understanding the lowest point of ATC and AVC. So this is a graph that is from the notes. It explains us the very important concept of how do we get the lowest point of ATC and lowest point of AVC given we are given only this graph. So a lot of times we are given only this graph and they ask us what's the point where marginal cost is at its minimum, and the answer is marginal cost will be at its minimum where at point A, because look at this guys, after point A, when you look at this graph, after point A, TC starts to rise at a faster rate. Prior to A, TC starting is rising at a slower rate, and then after A, TC starts to rise at a faster rate. So marginal cost, let me write this, MC is at its minimum when TC starts to rise at a faster rate. And that's exactly why it is because of the law of diminishing return, right? And that's why, look at this, at point A, your MC is at its minimum. Now, the second thing we need to ask is, okay, where is TVC at its minimum, or where is ATC at its minimum? And the answer is that for us to find out ATC at a minimum, we need to draw basically a line. Basically, ATC is derived at each level of output. If I want to derive at each level of output ATC, I can derive it from the slope of a line that is drawn from the origin to the TVC curve. So if I draw various lines like this and keep on finding the slope of these lines, I can get myself what we call the ATC curve. So the slope of this line, this line, this line, this line, all of these slopes are basically the slopes of all of these points can give me what we call the average variable cost curve. Now, the point that where you can see this, if you draw a line like this, the point will be the flattest at B, and that's the point where we will get ourselves the minimum point of AVC. So in order to find the minimum point of AVC, that will be the point where the slope line that I'm drawing from origin to the total variable cost curve is the flattest, and that's where B is. Now, same concept, where is the point, where is TC at its minimum? Well, I draw a line from origin. So let me look at it, draw another color. I draw a line from origin, and I keep on taking it to the TVC curve, and all of these points are points. If I find the slope of these points that I've drawn, I can get myself my ATC curve. These are all the values of that slope that comes from these green lines, but you can see this, that it will be the flattest at this point. This point C and this point B is actually tangent to the total cost and total variable cost curve, and these points where it's tangent and it's the flattest are the points respectively where your ATC and AVC will be minimum. So a lot of time examiner will give us this information and will ask us about basically where is total cost minimum, and the answer will be draw a line from the origin all the way to the curve and find that. Sometimes they may give you this kind of a graph as well, and I want to explain, this is an important concept to understand. Sometimes they may just give you total cost curve and they say, okay, where is MC minimum? You'll be like, oh, that's easy, MC is minimum in Q1, because after that TC starts to rise at a faster rate. Then they say, where is, okay, from this graph only, where is AVC minimum? And you'll be like, oh, okay, for that I basically need to draw my total variable cost curve. You don't need to, because total cost is just like total variable cost curve, except for the fact that total cost has fixed cost added to it. So if you just remove fixed cost, you will come back to origin. So rather than that, assume that this is your origin. If I assume this is my origin, then this curve will become my variable cost curve, because if you go back to this diagram, the difference between TC and TVC is simply fixed cost. So what I do is simply treat this as my origin, and draw a line like this. This is the point, so let's call this point A. This is the point B where my AVC will be minimum, because I'm treating my origin to be this point. But if I treat my origin to be normally this point, then I draw a line, and I'm going to let me draw a line like this, something like this, and I find myself point C, which is where my total cost is also, or ATC is minimum. So this Q3 is where ATC is minimum, this Q2 is where AVC is minimum, and that's Q1. So that's how we figure out our points from our total cost curve. We can find out a point where ATC is minimum, AVC is minimum, and MC is at its minimum.